The question says that there is a ball which is dropped on a floor at some height h, let us say, and elastic collision takes place. Therefore, the speed with which it strikes is root over 2gh, and the speed with which it rebounds is another root over 2gh, and it is going to attain the same height from where it has fallen. Now, let's see what the question is. The collision, as it is perfectly elastic, find the average force exerted by the ball on the floor or by the floor on the ball, both are same, during a long time interval. See, here if it is long time interval, so whatever is true for one collision will be true for the successive collisions. So, what is the change in momentum during one collision? The change in momentum will be m times root over 2gh minus m times root over 2gh, that is 2m root over 2gh. Now, once it collides, it goes up and again falls down. Therefore, there is a long time taken to change this momentum while colliding with the floor, and that time interval will be time to go up and come down, that is 2u by g, so 2 times root over 2gh divided by g. So therefore we can say that the average force will be equal to the change in momentum upon the time interval, that is 2m root over 2gh divided by 2 times root over 2gh divided by g. Upon simplification, we get mg. So mg is the average force that this particle exerts on the floor over a long duration of time, irrespective of the number of collisions it is undergoing with the floor.